And part 2.
It's Miss McConnell.
I don't need to say my name. They know who I am.
And Mr. Huff.
And you know who.
Oh my goodness. Okay, so in number 2, we're looking at using graphs to solve logarithmic equations. And we already talked about the range a little bit of the function log base 2 of x. And then using the structure of exponential equations, we know that as x goes to infinity, f of x will continue without bound to infinity as well, but that rate of change while increasing across the entire domain is increasing at that smaller and smaller rate as x goes to infinity. So we have to go out pretty far to the right to get even relatively small outputs. So we're going to look at that with f of x equaling 10, and we want to figure out for what x value will f of x equal 10. So if we have f of x equals log base 2 of x, we're trying to figure out what x value will get us an f of x of 10. Now, we saw several ways to do this. Some folks just kind of thought about it as 2 to the 10 power equals what? So they rewrote the function as 2 to the 2 to the 10th power equals x. Some students even thought about it as let's undo this log base 2. And in order to do that, you can do what we call exponentiating. And you can take everything, you can put it to a power. And so that's called exponentiating. We're putting a base of 2 and making the equation itself an exponent, and that keeps the equation equivalent. So then you have a base 2 exponential and a logarithmic base 2. So that undoes each other, and lo and behold, you end up with the exact same equation. Ooh. So when you do 2 to the 10th power, you get that x has to equal 1024. One thing that you might want to think about is looking at the Desmos graph and make sure that your x values go out to at least 1024, while your y values only go up to, say, 12. And then look at where the intersection would be if you had, say, like an equation y equals 10, right? F of x equals 10, and see where that intersection would be. You would notice the x value has to be 1024, yep, which is significantly farther. If you think about on this graph, we have y equals 4 here. We have to go all the way out to get that value. And then I'm going to go ahead and let Mr. Huff talk about 2b to finish this up.
So what value of x is log base 2 to the x, or log base 2 of x equal to 20? And it is, notice that this is, again, our f of x is equal to log base 2 of x. And so we're saying at what value of x will f of x equal 20? And we can set up the same exact relationship. Log base 2, your computer is on fire.
Yeah. Sorry for the technical difficulties, folks. We are, I just updated my computer. I'm sure everyone can relate to this, so it's having a couple glitches.
And so we can do, again, the same exact thing that we did over here. I prefer to just do the whole rewriting thing. So if I rewrite this it would be 2 to the 20 is equal to x. Or you could exponentiate by raising both sides to the 2. And so x in this case will be, 1,048,576. So just to kind of reiterate the fact that this logarithm is always growing, the y values are always increasing, but the pace at which they increase, the time or the number of x units we have to move out on the graph to get 1 unit of an increase starts to extend. And so notice that we only, between 2a and 2b, we only did a 10 unit jump for our outputs, 10 to 20. But we went from an x input of 1,024 to an x input of 1,048,576. Which is, what do you...
I'm showing how. So if you think about this in terms of like a slope, in terms of an average rate of change,
Oh, it's stupid big.
I mean,
It's
close to
basically zero.
It's
Yeah.
close to zero. It's going to be 1 over, 512 just to get from.
Yeah, it would be 20 minus 10 over. Oh God. 1048576 minus 1024.
You can see that your average rate of change there, if we were to even calculate a slope, is just so small.
Yeah, it would be about zero.
Right. So one thing we also want to point out is that we have culminated together some additional practice problems to help you study and develop your understanding of logarithms and how they apply to exponentials. And this is going to be really important for you to examine. And please see us with any questions on this. If we get enough of the same question, we'll go ahead and make another video.
Ooh.
All right. Enjoy the rest of your day.